Welcome back to the second portion of our Chapter 5 lecture in Engineering Economic Analysis. We've so far talked a lot about the background of present worth analysis, the assumptions we make in present worth analysis, and now we're going to move forward and actually do the calculations involving present worth. So last video, as we left off, we talked about the three different types of present worth analysis problems we'll see. The first type then being that the analysis periods are equivalent. So if the useful lives of different alternatives are the same, then we're going to use the useful life as the analysis period. This is the easiest analysis method. I'm sure that makes sense because if the useful lives are the same, then we're just going to use that as the analysis period. There's really no other calculations or conversions involved. Okay, so this then is kind of our basic formula. So we're going to say my net present worth is equal to the present worth of my benefits minus the present worth of my costs. And you can think about this then with regard to cash flow diagrams. So anything above the middle line is a benefit, anything below the middle line is a cost. And we tend to shorthand this with just this writing: NPW, or net present worth, equals the present worth of benefits minus the present worth of costs. Sometimes you'll be asked in a problem to find the net present worth of your costs. In that case then, you would just switch these two terms around so that your costs are positive relative to what you're being asked. And we'll get to an example like that in just a minute. Okay, so here's our first example, and this example then focuses on having equivalent useful lives. So a firm is considering which of two mechanical devices to install to reduce costs. Both devices have useful lives of 5 years and no salvage value. Device A costs $1,000 and can be expected to result in $300 savings annually. Device B costs $1,350 and will provide cost savings of $300 the first year, but will increase $50 annually, making the second year savings $350, the third year savings $400, and so forth. With interest at 7%, which device should the firm purchase? So I don't know about you, but I read a big word problem like this and I kind of need to simplify it. So I'm going to simplify it in this table. So here I have device A. It costs $1,000, but it's going to save me $300 annually. So when you're doing these types of problems, I want you to be able to just look at that $300 annually and tell yourself, oh, that's going to be a uniform series. $300 is going to equal A, which is a uniform series value. And then I have a useful life of 5 years, meaning this device or whatever it is I'm installing is only going to last me 5 years. Okay, my other option then is device B, and that costs $1,350, but it has a savings that goes from $300 to $500 annually, and it increases by $50 each year. This one also then has a useful life of 5 years. Okay, so because the useful lives are the same or equivalent, we are then going to analyze this using an analysis period or a planning horizon of 5 years. Okay, so the way I approach every single one of these problems is I draw a cash flow diagram for both alternatives. So here I have device A, and I spend $1,000 right now, today, at time 0, so that is a present value already. So I don't need to convert that at all. It's already a present value. Okay, so then these up here are my uniform series, or an annual savings of $300. Okay, so I write my present worth formula. I just say subscript A because that refers to device A. So the present worth of device A equals the present worth of my benefits minus the present worth of my costs. Okay, so I do this calculation. So I have $300, which is my A, times P given A, comma 7% for 5 years, minus my cost, which is $1,000. Okay, so I look up that factor in the back of the book, and I solve, getting a present worth of $230. So what that means then is, in order to have this cash flow diagram or this assortment of costs and benefits, I then would be saving $230 today. So that sounds pretty nice. Okay, so now let's look at the cash flow diagram for device B. So for device B, this one's a little more complicated, but you can see right off the bat that I'm going to have a gradient involved. Okay, so I spend $1,350 today, and then I have a steadily increasing savings starting at $300 going to $500. Okay, so I write down my present worth for device B, And this time it's a little bigger, and that's because I then have a gradient to include. So I have my uniform series value, which is 300, so I convert my A value to a P value, and then I add to that my gradient, which is $50 per year, 7% for 5 years, and I subtract off my costs. Okay, so I look up those factors in the back of the book, and I get a present worth is $262.40. So once again, that just means that whole cash flow diagram is equivalent to $262.40 today. So that is a benefit, or that is money coming to me or deposited to me, $262 today. So since device B has a larger present worth, which is a benefit in this case, we would choose that one. So remember that slide in the last video. If things are benefits, we want the larger benefits because we want the larger positive value. If things are costs, we want the smaller cost. So in this case then, we choose the larger of the two benefits. Okay, so moving on. If now my analysis periods of my two alternatives are not the same or not equivalent, then we would use this next method. So if the useful lives are different, then we first need to come up with some common analysis period that makes sense for all the alternatives. So frequently, we would use something called a least common multiple of the useful lives as an analysis period if it makes sense to do so. So be careful, in some cases the least common multiple might be too long to be reasonable, in which case you'd want to use a different method to find a common analysis period that works for both. So basically you want to use a common analysis period that reflects other analysis decisions. So an example I like to think of here is if I have two alternatives, one that has a useful life of maybe 5 years, one that has a useful life of maybe 20 years, we would then look at those and find a least common multiple, which would be 20. So we would then use that 20 years as my analysis period for both alternatives. However, if I kind of have unrelated useful lives, like maybe 7 and 13, those really don't have any common multiples until I get into the 90s. And I'm not really going to want to do a planning horizon or an analysis period on something in the 90 plus years. So that doesn't really make a lot of sense. So in that case, maybe you would say year 14, because 7 would go into 14 and 14 would be close to 13. So anyway, just be careful when it comes to different useful lives. Okay, so let's look at an example regarding this. A purchasing agent plans to buy some new equipment for the mailroom. Two manufacturers have provided bids. An analysis shows the following table. Which manufacturer's equipment should be selected? Assume 7% interest and equal maintenance costs. Okay, so I have this one manufacturer called Speedy, who it's going to cost me $1,500 for this equipment. That equipment then will last me 5 years, and at the end of those 5 years I can sell it for $200. I then have another manufacturer called Allied who will cost me $1,600 for the equipment, but that equipment then will last 10 years, and at the end of those 10 years I can get $325 back. So any guesses on which one we think might be a better deal? So the thing I like about economic analysis is the final answer isn't always what we maybe guess up front. In this case it might be, but sometimes it's not. Okay, so I'm going to rewrite this table just so I have all the information in front of me. And then I'm going to draw each one's cash flow diagram. Okay, so first I'm going to draw Speedy's cash flow diagram. And before we get started, we maybe need to decide on a common analysis period. So if you notice, they have different useful lives. So this one is 5, this one is 10. So we need to decide an analysis period based on those two different useful lives. So I'm going to say I'm going to use the least common multiple method, and I'm going to choose the least common multiple between those two values, which would then be 10 years. Okay, so I draw the cash flow diagram. So I'm spending $1,500 today, right now, year 0, to get this equipment, and then I'm going to sell it in 5 years. Well, these two values are just my original investment. However, I am continuing on with this cash flow diagram 5 more years. So what that means is since I sold the equipment here at year 5, I need to buy more equipment at year 5. So I spend $1,500 again. That equipment then is going to last 5 years, at which point I'm going to sell that new batch of equipment for $200. That second group then I'm going to call my replacement investment. So just kind of be careful when you are maybe getting a salvage value and spending more money on new equipment in the same year. Okay, so if I do this calculation, it looks kind of ugly, but the reason I like drawing the cash flow diagram first is so that you can visualize each of these individual values on the cash flow diagram that need to be converted to a present value. Okay, so here I'm going to analyze my costs. No one told me to, but I'm just going to assume that my costs are going to be greater than my benefits this time. Usually you'll be asked to find either a benefit or a cost. Here I'm just finding a cost, really just to show you a different example of that, but normally it'll be specified. Okay, so all that means really is that my costs are going to be positive and my benefits will be negative. Okay, so I'm going to say my present value or my present worth of my costs for the Speedy manufacturer is going to be $1,500. So once again, notice I didn't have to convert that because it's already a present value, plus $1,500, that's a future value that I want to convert to a present value. That is a 7% and that is occurring 5 years from now. So that's what a future value means. So then I subtract off the benefit because I'm looking for a cost. So I subtract off $200, which is a future value, and I want to convert to a present value, and that is 5 years away. Then I subtract off 200 again and convert that 10 years away. Okay, so one thing about this is if you notice this factor right here and this factor right here are the same. So really something I can do is I can factor that right there out, and I can then consolidate these two. So I now have 1,500 minus 200 all times that factor minus 200 times this factor. So you don't have to do it that way. You can leave it as the two separate ones, but this is just kind of something to save you time. Okay, so I find out those respective factors and I solve. So my present worth of my costs is equal to $2,325. So what that means is if I spent money today for this cash flow diagram or for this equipment from Speedy manufacturer, then I would be spending today $2,325 on this equipment over the next 10 years. Okay, so let's leave that on there to compare. So now let's draw the cash flow diagram for Allied. So I spend $1,600 on the equipment today and I get $325 at the end of 10 years as a salvage value. So I write out each of those values. So I say $1,600 already is a present value, so I don't have to convert it, minus $325, finding a present value given a future value after 10 years. So I look up that factor and I get a present worth that's a cost of $1,435. So once again, all that means is in order to pay for the equipment from Allied, I would need to spend $1,435 today for that equipment over the next 10 years. Okay, so then if I compare these two, so keep in mind we are comparing costs this time. So I would want the smaller of the two costs. So since Allied has the smaller present worth of costs, we are going to choose this one.